Your vectors, just like your ordered pairs, your ordered pairs are always the horizontal, comma, the vertical. So the vector does the same thing, tells you how to move horizontally, then how to move vertically. So we're starting at A, because A is the tail. And I'm just going to sketch this, so let's see, 1, -1. There's our A. Then our vector is 2, 3. So that means from 1, -1, we're going to go, let's see, +2. So that means go left or go right? Go right, because it's like before, so we're going to go right 2, and then up 3. So go right 2, up 3. Here's our vector A to B. Okay, now the vector, it looks a lot like a ray. Remember from geometry how you had a ray, where the tail starts and then where the ray ends. So that's how you read the vectors the same way. It's just instead of having the double, the arrow on top and bottom, it just says looks more like B. Where does B? What point is B at? You start at 1 and go right 2. That takes you to 3. And then you start at -1 and go up 3, you end up at 2. So all we did was start at A. And we added on our vector to get 3, 2. Because our vector tells you how to move from the first point to the next. You know, CD has a displacement 2, 3, and D is at -2, 5. What is C? So again, we can, a lot of these when you start making a sketch helps, at least it helped me visualize them quite a bit. So we're at -2, 5. So there's our D. And that was after we had moved, you know, none of these are to scale. That was after we had moved 2 to the right and out 3. Well, where did we start?
From C or from D?
What is point C?
Oh, so -4, 2.
-4, 2. Yes. How'd you get that homework?
Well, I drew a sketch like that, so I went from D because I knew that I had to get the point we were at. I went down 3, so I knew we had to subtract 3 from 5, and we had to subtract 2 from -2.
Okay, just look at where you end up at D. You end up at 2, -5. But that was after you moved your vector 2, 3. So it's like we're taking our ending point minus our vector, and that gives us -4, 2. You know, the reason they had you do all those graphs in 610 is if you do enough graphs, you can see how to relate to the vectors algebraically, where you don't have to draw it out every single time. Okay, but if you don't take the time to do all those graphs, then I think it's very hard to jump to this. That's why I wanted you to have 610 done before class started today, because it had to do all those graphs and stuff. Okay. If P is 0, 3 and Q is 1, 2, find the displacement of PQ. Okay. By the way, PQ, vector PQ, and vector QP, why are those different? Omar?
Because with one, you're going forward, and the other you're going back. So one would be positive in some term, and one would be negative.
Right, exactly. Think of it this way. If I walk from here to the door, and then I walk from the door back to here, I'm walking along the same path, the same line, but I'm going the opposite directions of each other. You know, one way I'm going to the door, one way I'm going away from the door. Even though it might be along the same line on the door. Okay, so they have different directions. So if we're going P to Q, where do we end up? Well, just we end up at Q, right?
Right.
So we could do point Q minus P. Where did we end up and where did we start? So then that would tell us how much it changed by. Just like Carl, if I told you, let's see, next week you're going to have, you have $10 this week, you're going to have $25 next week. How much money did you gain? Or will you get 15? How'd you get 15? 25. You took the amount you're going to end up with minus where you started. This is the same idea with points. We're starting at P and going to Q. We start at P, go to Q. So if we want to see, well, how much did we change by to get from P to Q, we take where we ended up at the end of the next week minus where we started. Okay, so then here we could do Q, so 1, -2, minus 0, 3. So our vector would be, let's see, 1 minus 0 is 1. -2 minus 3 would be -5. Okay, and then Q to P, well, we would just reverse that. So we do our point P, because that's where we're going to end up now. 0, 3, minus our point Q, because that's where we started now. 1, -2, so I'll give us -1, 5. Okay, so the same numbers, but just with opposite signs, because of that idea we're reversing the direction when we change our starting and end points around. What I would like you to do, by the way, why did they use O for this one? Yeah, O for the origin. Okay, I want you to, below each one of these vectors, OA, OB, OC, so on, write what the vector is. You don't necessarily have to show your steps to get there, but I want you to write what the vector is. And then off to the side, we'll write out the ones that are equivalent, the ones that are the same vectors, basically. We have figured here, we're supposed to write the connections between A, B, and D. Okay, so if we started at A and added D on, so we're starting at A, adding vector D on, where would we end up? B. So this is basically saying if we start at A plus vector D, we end up at point B. Now, when I work with vectors, no matter what the problem is, I start with this basic idea. I have a starting point, okay, which they call the tail point. I'm going to add on the vector and we're going to end up at the head point. Now, algebraically, what's one way we could rearrange this to get the D by itself, for example?
B minus A.
Okay, right. So then, using algebra, basic algebra, algebra 1 level stuff, you can see that D is going to equal B minus A, which we looked at before just by the sketching. Okay, you could also look at if we had point B and we knew D, how could we figure out A? In other words, how could we get this A by itself? B minus D, okay. Or A is equal to B minus D. We could start at our tail point, subtract our vector, and we would get, we'd start at the head point, subtract our vector, and we get the tail point. Start at the end, subtract how much we moved, and we ended up with where we started at. So, okay. And there are other ones we could get to, other relationships.